Hello everyone, welcome back to Turo's Cove Media. Whether you're here to watch, learn, or you're just needing to take some time to decompress, I'm glad you're here. I hope you had a wonderful weekend and I'm excited to get back into our series today. So we've been working on our very own game of Tetris, and at this point we have the window, we have our game grid, we have our Tetramino pieces. We can move those pieces, they automatically fall to the bottom of our game area, and we can also rotate the pieces so that we can try and fit everything into into place how we want it. So first things first, what that we're going to do today, first thing we should always do is we're going to quickly run our code to make sure everything is working as it's supposed to. Just because who knows, something may have changed, shouldn't have, but we want to make sure. So there we go, our pieces are falling down. And a big aspect of Tetris that is currently not in the game is we need to clear the lines that are filled. And so we'll see how quickly I can show that. Depends what pieces I get, because this is random. And just also making sure everything's working right. Everything moves, everything rotates. I can make it fall faster, and there we go. And so if this, in a completed game of Tetris, when that happens, this very bottom line should have cleared, but it won't. So that's what we're going to be adding today. We're going to be adding a new function to help make that happen. We're going to exit out, and then we're going to work on the function, and then I'm going to get into a little bit more detail on what's going on and how it works. So I'm just going to scroll down a bit. And so with functions, the actual order, in at least this case, because each of these are standalone, where I put them in order of everything doesn't matter. We just want to try and keep, ideally in this case, we're just trying to keep everything as logical and as organized as we can. More for ourselves when we come back, say we need to change something or look for something. So our new function, we're just going to call clear lines. And with that, we're going to be passing our grid. So that's our game area. And so we're going to create a variable called new grid. And what it's going to be doing is it's going to be looking at each row for rows in our grid, and all it's looking for, if any of the cells are empty. So as long as in a row there's at least one empty cell, it's going to keep it. Per cell in row. And then we're going to create a second variable called cleared equals rows. And so what this is, any rows, so I'm getting ahead of myself. So in our new grid, if a row has at least one empty cell, it will stay. If the cell is filled up, if the row is filled up with, it's full of Tetramino pieces, it'll clear it. It's not going to save it. So that's what this clear is going to be. Anything that is, for however many is filled, we're going to clear it out. We're going to delete them. New grid. 4 in range. Cleared. New grid. Dot insert 0 0 in for blank in arrange columns. And we're going to then return. Sorry, I'll go back to this in just a moment. Let me get this finished typed out. Okay. So again, we're going through as long as for every row that has a 0 in it, we're saving it. We have a second variable, and what it's doing, it's comparing if the number of rows is the same as our length, clear just can be 0, nothing's going to happen with that. But if length is less than rows, we want that value to be saved, because we're going to clear out those rows at the bottom, those rows that are filled will get deleted, and everything above it is going to get shoved down, and it's going to insert a new, however many new rows above it. Again, player's never going to see it, but that's functionally what's happening in the background. And and before we add this to the actual game, I'm just going to provide a little bit of a demonstration. So what's going on here, let me get the pencil, and I'm going to write, I'll do white. So all the blanks, all these grids with no tetramino pieces, these are zeros. Now we get to our first tetramino piece, and we have 1 and 0 and 0. And just to speed this up, I'm only going to mark the grid places with tetramino pieces. Except for this, I'll mark that. 1, 1, 1, 1. So nothing's getting deleted at this point because there's at least 1 0 in every row. But as this piece continues to fall, what will end up happening is let me mark it. There we go. What is going to happen is it's going to fill up. Let me zoom in just a little bit. Really, I don't have to be so exact, but I just want to be kind of who I am. There we go. So 1, 1, 1, 1. And just for the sake of it, there we go, 0. So zeros, zeros, and then we start getting some ones. Again, as long as there's 1 0 in a row, it's not going to do anything. But this bottom row is now filled up with 1s, and so now the game's going to see that, and it's going to clear it out. Really what's going on, it's actually just deleting this row completely. So this becomes the new bottom, and actually that would maybe a better way of showing it. You just get a square there. There we go. That's actually, oh goodness gracious. It's actually just deleting this bottom row completely. But in many ways what's functionally happening is it's going to drop down the way we're writing it to our screen. It's actually just going to insert new rows above it. I'll just do this real quick. So it takes everything, deletes it, we get a new row, and the way the stacks work, this becomes our new 0, and it pushes everything else down. So screen-wise, it just looks like everything falls, and that's what we want. And so that's what is going on. And so now everything else is zeros, and we can continue on. Our next piece will be created, we'll drop it down, and we will continue our loop. So we'll get right back to our code. Oh, there we go. So now we're going to add, we don't have to add too much. We're just going to come down to our while loop. So this is the game running. And all we're going to do is when it checks for collision, after we check, we lock our tetramino pieces in place. But before we spawn the next piece, we're going to check and see if we clear the lines or not. Lines. Grid. All right. There we go. We're going to run our code, and we're going to make sure it's functioning like it's supposed to. Hopefully I didn't miss anything else as I'm going through the notes. Happens all the time. I'm very bad about it. Alright, so we just gotta play our game for a little bit and see what is gonna happen when we fill out a line. It should actually be pretty quick. There we go. See if it behaves like it's supposed to. There we go. And now the core feature of the game is finished. We can now clear lines, and I will try and set this up so I can see what happens when I do multiple, or try to. See if the game will behave itself. Alright. Can we get a proper piece to finish this out? Maybe. That's why it's in going through and checking what you've done, making sure it's running properly. This can be part of the time-consuming thing, because what we're trying to make specific things happen to see if what occurs. And there we go. Okay, we know we can clear one line, we can clear multiple lines, and this core game loop is ready to go. So I'm just gonna stop it, and again, you can just exit out. That's why in everything we do, we're gonna have this line right here is for event if Python quit. So just so that whether we're exiting out of it or we're stopping it within our coding environment, the game's just gonna quit out. Alrighty, well, we have our core game loop ready to go. And from here on out, we're just going to continue to add on some features, make the game feel better. We're going to be working on adding the scoring, adding some difficulty to the game by speeding up the tetrameter pieces after we hit certain milestones and however many lines we've cleared. I thank everyone for stopping by. I hope you have a wonderful week, and please stop by and catch the next episode this week. Have a wonderful time. Catch you later.